Okay, so we have our last set of notes for chapter 10, 10-4, and we are not going to take a quiz or a test. Those checkups that I put in each week, those go towards your grade for the quiz part of it. So we will move on after this set of notes and practice. Solving. We're going to solve equations that contain radicals, and our solving steps are the same. And I want to remind you that the opposite of add is subtract, and multiply, divide. And we know that the opposite of taking the square root of something would be to square it. So let's go ahead and draw a line down our equal sign. The opposite of that plus 7 would be take away 7 on both sides. We're left with the square root of x equals 9. And then it says the square root of x equals 9. The opposite of the square root is to square. So we want to make sure we square both sides. Whatever we do to one side, we do to the other. And x here equals 81. So just going through your solving steps, just like we've always done. Example 2, draw that line down the equal sign. Again, what's different about this one is you have square root on both sides, but when you square both sides, it just cancels out. So the squared cancels out the square root. So we really just have 5t. I'm going to change that to plus and negative 11 to change everything to addition. And then t plus 5. We just got to get the t's together. So we know this would be a 1t. I'm going to take away 1t from both sides. And I have 4t plus negative 11 equals 5. The opposite of a minus 11 or negative 11 would be to add 11 to both sides. Whatever we do to one side, we do to the other to make sure we keep it balanced. So we have a 4t is equal to 16. And when we say 4t, we know that operation is 4 times t. That's the operation when you have a number next to a letter. It's multiplication. The inverse of multiplication is division. What you do on one side, you do to the other. And t equals 4. So those are 2 examples. I have 2 more examples that we want to make sure that we get down as well. So let's jump on to example 3. Here at the very top, you can see what's called extraneous solution. It's going to be a new vocab word, okay? And you're going to see when we're done with this one that we are going to have an extraneous solution. We want to go ahead and get that written down. It means that it does not satisfy the original equation. So does not satisfy the original equation. So with that being said, let's go ahead and draw a line down the equal sign. And we got to get rid of that square root. So the opposite of square root is squaring. So what I do to one side, we need to do to the other. So we're going to end up with n squared on the left, and then we have n plus 12. And what you're going to notice here is we actually have a quadratic. So this is taking us back to chapter 9. And so in order to solve our quadratic, we want to get everything set equal to 0. So I'm going to subtract my n and subtract my 12 from both sides. I want to have a positive n squared. So we're going to have 0 on the right. And on the left, we have n squared minus n minus 12. And so you can see this is a quadratic equation. Your a value is going to be the 1 in front of the n squared. We can look at this as plus a negative 1. And c is a negative 12. So we need to find all our factors of that negative 12. And so 1 and 12 Remember, we need a negative, so it's going to be opposites. And then we have a -2 and a +6, or a +2 and a -6, because we know that 2 and -6, and you multiply those, get you a -12. And then 3 and 4. -3 and +4, and +3 and -4. And we want to figure out which of these adds up to that -1 in the middle. Well, that's going to be this last one, the +3 and the -4. So now, this is a good review of chapter 9. We have n plus 3 times n plus -4 is all equal to 0. And if you recall, we have to set each of those equal to 0 to see what our solution would be. So let's go ahead and draw a line down our equal sign. We're going to subtract 3 from both sides. We have one of our values for n is -3. And then we add 4 to both sides for this other one, and we have our other value of n is 4. But we got to go back to that definition of extraneous solution, which means does not satisfy the original equation. And so when we plug numbers in to our original equation, let's plug -3 in. So if I plug a -3 in where the n is, equals the square root of -3 plus 12. Well, -3 plus 12 is a +9. And we know the square root of 9 is a +3. It's not the -3. This does not satisfy the original equation. This cannot be an answer. Even though we solved and we found that as one of them, for this example, it does not satisfy that original equation. If we put 4 in, going back to the original equation, 4 equal square root of 4 plus 12. Well, 4 plus 12 is 16, and when you square root it, you do get a +4. So my answer, and my only answer for this one, is n equals 4. So we do have to check and see if we have any what we call extraneous solutions. And my very last example is actually one where you're not even going to get a solution. It's going to be a no solution answer. So there's not even 2 choices to choose from where one of them is extraneous and one of them is not. This is just going to be flat out a no solution, and I'll show you why. Let's go ahead and draw a line down our equal sign. Subtract 8 from both sides. And we have the square root of 3y equals -6. Well, what it wants us to do is the square root, the opposite of that is to square. So we need to square both sides. Whatever we do to one side, we do to the other. And we get 3y equals -6 times -6 is a +36. And now, both sides, it says 3y equals 36. So we need to divide both sides by 3 because the inverse of that multiply is divide. And we get y equals 12. And again, when we go back to check our work, the square root of 3 times 12 plus 8 has to equal 2. And this doesn't work. 3 times 12 is the square root of 36, which is a +6. But when you add 6 and 8, you do not get the number 2. So this does not work. This one does not have a solution. The answer would be no solution. So go through your solving steps. I don't think that'll be the hard piece at all. Make sure, though, that you do check your answers to see if some of them are no solution, or if you are solving the quadratic, if you have what we call an extraneous solution. Have a great day.